All right, so rotation. So rotating something is going to deal with degrees. Okay. It says most of the time rotations are completed in regards to rotating around the origin, okay, in increments of 90. So we can rotate 90 degrees, 180, 270, 360, 720, 540. Take 90 and multiply by anything that you want, and we can do those types of rotations. Those are easy rotations, okay, in comparison to all the others. But there is nothing saying that you cannot rotate something 33 degrees if you wanted to, okay? Now, we're not going to have a structured rule for that, but I'll show you the technique for rotating something regardless of the degree of rotation. So this is the idea, okay? What happens is we're going to start with, I know this image here that I've drawn is a complete image of the entire process. So I'll try to get you to see how this is done step by step. So the first thing you're going to do is you're going to start with and let's just say we're start with point A. That's going to be the pre-image. All right, and we know what we want to rotate around. Okay, doesn't matter what point or anything like that. You just choose a point that you are interested in rotating around. So that point that we're interested in rotating around right now is this point right here. Okay, so we start with 2 points. Does that make sense, everybody? Okay. We are then going to connect those 2 points, whether visually or actually physically, go through and connect those 2 points together. Okay? And that ends up being one side of our angle that we're going to use to do rotation. So we take our protractor, okay? We'll take our protractor, and so let me just draw a real haphazard protractor here real quick. We'll put our protractor with the center right there. You know, that's our protractor, right? Everybody okay with that? We'll put it right there, and we'll, along the base of our protractor, we will line that up with this first line that we drew. Okay? And let's say I want to rotate point A 90 degrees. I would go find 90 degrees on my protractor. I would make a mark on my paper. Does that make sense? Once I make that mark, I'm then going to take my protractor off my paper, and I'm going to now go from this point to that mark with a straight edge. And I'm going to extend as far as I can. And I get that line right there. Does that make sense? So now I started with this segment, and I've now butted up my protractor and made this a right angle. Does that make sense? Okay. So what that tells me is that on this ray of my angle, okay, on that new side of my angle, somewhere is A prime, the point that I'm going to rotate. Okay. Now just think about this. Because when I do a rotation, distances are saved. They're preserved. It's an isometry. This distance right here, okay, if I can figure out what that distance is, then I can copy that distance over here, and at the end point, then when I copy it, that point right there would be corresponding to that point there. Does that make sense? So that would be then A prime. And now I've rotated point A 90 degrees around that center of rotation. And then I do it for B. I do the exact same process for point B, do the exact same process for point C, and however many points I need to do that to, and I will effectively rotate my image 90 degrees. Now, if I wanted to rotate it 30 degrees, then all I do when I get to my protractor, I select 30 degrees instead of 90, and I can rotate 30. Does that make sense? Now, the way that we haven't done much of this, but the way that we would kind of capture that distance right there is that you would take a protractor, or not a protractor, sorry, a compass, and I don't have,
There it is.
So you guys are probably familiar with compasses being these things, right? Okay. So you would take your compass, and all a compass is a device that draws circles, but it captures distances. Okay. So I would take this and I would make it big enough to where I could put a point there and the other point here. And then I would have that distance frozen on my compass, right? And then no matter where I go, as long as I don't change my compass, I can replicate that distance. So once I have that distance captured on my compass, so here's my teacher edition compass. So I put a marker, find a marker. So right now I have that distance on my compass, right? So if I want to find out where does that distance stop over here on this new ray, basically all I do is I put my compass right there, and then I come over here, put a mark. Probably shouldn't have done that, but now I would know exactly where that distance is. It's a direct copy of this distance. Does that make sense? Because it's a radius of a circle. So that's how we would. This is why I say you need a protractor and a compass to effectively rotate something more. I guess I don't say more, but in a measurement that is non-90, not a multiple of 90. Okay. Here are some rotation rules that I would like to kind of investigate with you. Instead of just giving them to you and saying that's what they are. So let's start with a random point. Doesn't matter. Okay, so I'm going to start with point A here. So you guys don't have to write this down. Just kind of watch this. And these are rotations around the origin. This is what all we're talking about right now. Rotating around the origin. So there's A. Let's call this point O for origin, okay, which is 0, 0, correct? If I rotate, let's see here. Now we have to decide whether we want to go counterclockwise or clockwise. And what I want to do real quick, I'm just going to bounce back and make sure I've got these written correctly. So the rotation turns a figure through an angle about a fixed point called the center. A positive angle of rotation turns the figure counterclockwise. Okay, so just wanted to make sure some textbooks, just depending on what rules you are using, these rules are talking about moving counterclockwise, which is in alignment with what we do in trigonometry. Yeah, so that's the most common rotation that you'll do, but we'll talk about moving maybe clockwise if we wanted to. So it says we're going to move counterclockwise 90 degrees. Okay. So what has happened? What GeoGebra is doing there is saying, okay, if we were to draw a distance from A to the origin, okay, now put our compass, not our compass, our protractor on here, and find 90 degrees on our protractor, and then once we find 90 degrees, we then extend a ray through there. Then it's saying, okay, capture this distance on a compass. So basically what it's saying then is do something like that. Does that make sense to everybody? And then if wherever this circle intersects that ray, I know exactly then the distance from O to A prime. And hopefully you see that O to A is a radius, right? And O to A prime is another radius. And what do we know about two radii of the same circle? They're the same. So this point A is the same distance from the origin as A prime is, which has to be maintained in regards to working with rotations. So my hope is that you can see it. There is a right angle here. Okay, if I were to ask GeoGebra what is this angle right there, Now it shows me the reflex angle of 270, so that means this one here's got to be it's got to be 90, right? What do you notice happens to the ordered pair? If I start with 5-2, what did it do here? A flipped, and the first one became negative, right? Let's see if that's maintained as I move this around. Let me just get rid of this ray real quick. So if I go there, do they flip? 4-5 becomes 5-4, and does this one become negative? Same thing there? Okay, so we're seeing that it happens a couple times when we have A starting in the first quadrant. It's easy to see what happens when it goes as a rotation in the second quadrant. What if I started here at A, at negative 4-8? Do they still flip? They still flip though, right? They still flipped. Well, but think about this. So if I start with if I start with AB, what we're seeing so far with a 90-degree rotation is that they flip, and this one becomes negative, right? So let me ask you this. If you start with negative 4-8, and they flip, it turns like that, right? And then you make the first one negative. Is that this point? So that rule that we saw and established maybe in the first quadrant is still showing up here when A shows up in the second quadrant. Let's see if that happens elsewhere. Do they flip? Does this one become negative? Because when I flip, it's negative 4, negative 6, right? But then I negate a negative, and negating a negative turns this into a positive. Okay? And then we can do the same thing over here. They flip, so 6 negative 4 flips to negative 4, 6. And if I negate the first one, it turns into a positive. So what I want to show you is that rotating 90 degrees. I don't like this. I do not like the structure that I have written here. I did this intentionally to remind myself to talk about this. They're always going to say R sub 90. Okay, now they might say, so we've been using a capital R for reflections. Now they put 90 degrees down there. I have seen some textbooks and some tests use a lowercase r and then 90 down there. It doesn't really matter the case of the R that you use. What is important is that you see 90 degrees. Okay, this is the only transformation that is using a degree. So my hopes are that you realize then this is not a reflection, but it's a rotation because it's a degree marker. Okay. Now, like I said, I don't like this because it's an ordered pair x comma y, and then when we flip it, it becomes an ordered pair negative yx. But this is still, because of the structure of ordered pairs, this is still an x value. Does that make sense? It's just the opposite of whatever this was. This is still a y value. It's just whatever this number here was. I don't like that, okay, because it confuses people. So what I always do, and this is where I use the A, B stuff, if we have a point that we started with A comma B, where A is an x value and B is a y value, then it turns into the opposite of B comma A, where this is still an x value, this is still a y value, but they relate back to whatever these two numbers were. Does that make sense? So that's still x, that's still a y, still an x, still a y. Okay? But this x and y relate to these x's and y's based on taking the opposite of that number right now as my x and leaving that x value then as this y value. Does that kind of make sense? So if I ask you, let's say that I come down here and I say, let's rotate this image 90 degrees. Okay, so and about the origin. So this point right here is 2, 1. This one here is 6, 1. This is 2, 3, and 6, 3. 1, 2, 3, 4, 5, 6. Okay. So let's call this A. Let's call this B. Let's call this C. Call this D. I always like to just develop a kind of system, because if I can do the procedure with one point, then I just cut and paste that procedure to all my points. So I always like to stack them like this. Not saying it's the right way, not saying it's the only way, but I think it's a clean organization. So then that point 2, 3. So if I want to rotate 90 degrees, so if that's A and that's B, becomes negative B comma A. So A prime is going to turn into what? Negative 1, 2, right? I like to go through and just say, okay, all of these values here are going to become X values, right? So all these Y's become X's. So I always go through and go, okay, 1, 3, 3. And then they're all going to get negated, right? So minus, minus, minus. And that's okay. All of these values are going to become the Y's. So 2, 6, 6, and then 2. And now if I plot these points, negative 1, 2, so there's A prime. Negative 1, 6. Okay, B prime. Negative 3, 6. C prime. And negative 3, 2. D prime. We've now rotated that thing 90 degrees. And to double check, what I always do, and this could be something that helps you on a test if you forget these rules, okay? Because sometimes they'll give you the images, like, okay, what's the degree of rotation here? Well, let's go from A prime, draw back to the origin, and then draw to A. Does that look like a 90-degree angle? It does. Now we know algebraically that this is a rise over run of 1/2, right? This is a rise of so a rise of 2 and a run of negative 1, isn't it? So if I take slopes, I take a negative 2 over 1 slope and multiply it by 1/2 slope, I get negative 1, correct? Isn't that exactly the definition of perpendicular lines in the coordinate plane when their slopes are a product of negative 1? So I always do something like that. Or I can go to point D and go to D prime, and you see that is any right angle. And I can do that with every single point in its corresponding point in the image and pre-image. Does that kind of make sense on how to do that? If you can do that with 90 degrees, then the process is the same regardless of the measurement we use. So let's go back up here, and I'll go to GeoGebra, and we were rotating 90 degrees. Let's change that to 180 degrees. And if I start with a point like 8, 4, what's it become? Negative 8, negative 4. 10, 4 becomes negative 10, negative 4, right? So now positions aren't changing. The X's and Y's are just both being negated. I had an issue there. They're getting negated. What happens over here? Let's start with one of them being negative. So negative 6, 4. Okay, but don't I negate this? If I negate that, I get 6. If I negate 4, I get negative 4, right? So I'm still negating both coordinates. Same thing there. What about here? If I start with negative, negative, negate both those negatives and they become positive, right? So what we're seeing here, hopefully, is that when we do a rotation of 180 degrees, a rotation of 180 of A, B, it's the same thing as negative A, or it turns into negative A, negative B. So, okay? 270, a rotation of 270 degrees is very similar to a rotation of 90 degrees. Okay? So I want to rotate 270. Okay, so remember A is the original angle, so I'm going to rotate. So let's just look at the picture here. So 270 degrees would be rotating around that circle to there. Does that make sense? Okay. Now it looks like if I were to draw that there would look like a 90-degree angle, right? Okay, so we'll talk about that here in a moment. But if I'm going to rotate, I'm going to take A and move it along in a counterclockwise rotation, 270 degrees, it's going to fall right there. What happened? How do I go from this point AB to this point? I flip them, and then the Y value becomes negative, right? Okay. Does that happen? Whoops. Does that happen right there? Let's actually use a different point. No. I don't like using the same, like I don't like using points that are on the line y equals x and y equals negative x to make the argument. So let's make the coordinates different. So do I still flip? So if this is the point I started with, this is my pre-image, do I flip them and negate the y to get that one? Let's say we start down here. Okay, rotate 270 degrees. Does it flip them and make the y negative? Yeah, negating a negative produces a positive. So what we find out is that let's see here. Let's go write that down. A rotation of 270 degrees of A comma B, okay? It is the same as that 90-degree rotation. It still becomes B comma A, but it's got to be different than 90. 90 had a negative here, so then 270, the negative is going to go there. Does that make sense? So that's how I remember, because you can get these easily mixed up, okay? I remember that 90 comes before 270. So then when I have my image ordered pair of negative B comma A, I remember because 90 comes before 270. So in my ordered pair, because this term comes first in comparison to that one, I'm going to negate this one. So that's how I don't know how you're going to, however you structure it in your mind to remember which one gets the negative, that's how I do it. And then 270 comes second. So with the 270 rule, the second one over here gets the negative. Okay. But here's my question real quick. If I go to this here, we just said that if we take A as the pre-image, which was 8, 6, and A prime then becomes 6, negative 8. That is if I start with A comma B, it turns into B comma negative A, right? That's a 270 degree rotation counterclockwise. Okay. Now, if I start, let's think about this. Let's start with A prime as 6, negative 8. And I want to get back to A. Can I rotate this thing? So if I want to start, let's say this is my pre-image, and I want to get to that. Can I rotate that direction? And that direction would be counterclockwise, right? Okay. Actually, let's do it this way. Let's not start with A prime. Let's start with, because I think it might make it a little bit more simple. Let's start with no, we got to start with that. Sorry. If I start here and I want to go to A, how many degrees do I need to go counterclockwise? 90, right? Okay. Now, we know that if we start with a 90 degree, if I have A comma B, 90 degrees counterclockwise is going to be negative B A, right? Okay. Well, so I'm going to flip. So I start with 6, negative 8. I'm going to flip them. It becomes negative 8, 6. And now I'm going to negate this, so it turns into a positive. It's the same situation that we had up here, right? This rule going from A to A prime was a 270 degree counterclockwise rotation. This from A prime to A is a 90 degree counterclockwise rotation. Does that make sense? So that relationship there is what allows the following statement to be made. A rotation of, so note a clockwise rotation of 90 degrees, and this is because things are circular. Okay, if I want to go from there 90 degrees clockwise, okay, so that's going to take me maybe down there. That would be the same thing as moving counterclockwise 270 degrees. Does that make sense? Okay. If we were to look back at maybe something, let's just put the all right, so let's say that we want to go from A to A prime. A be my pre-image, A prime be my image, and I want to go counterclockwise. That then is showing us that this angle there is 270 degrees, right? So I can do that. I can apply the 270 degrees if I want to go counterclockwise from A to A prime. But if I want to go from A to A prime, but go clockwise, is it the same? I got to get the same point that I got when I was going counterclockwise. So a rotation of 270 degrees counterclockwise is equal to a rotation of 90 degrees clockwise. Does that make sense? A rotation of 90 degrees counterclockwise is the same as a rotation of 270 degrees clockwise. Okay? Those are two very important rules for us because our rules that we establish with A and B for rotations are counterclockwise rules. So in your homework, the questions are going to say rotate this pre-image 90 degrees counterclockwise. The next one's going to say rotate 270 degrees counterclockwise. And then the next one's going to say rotate 90 degrees clockwise. Okay? In order to use our rules that we've established, if I want to go 90 degrees clockwise, I got to look at one of those formulas up there and say, okay, well, 90 degrees clockwise is the same thing as 270 counterclockwise. So I'll change the way the question is written so that I can use the rules that we have established for rotations. Does that make sense? Okay. That usually gets people. I think some of the questions train you to always be thinking, okay, every question is going to be asked counterclockwise, counterclockwise, counterclockwise. Then the next one they say clockwise, and you answer it incorrectly because you're not paying attention to that relationship. So just be careful with those. Is that something we can do? If I give you a list of ordered pairs? Because that's really all the problems that you've been seeing is simply giving you a list of ordered pairs. Now, the way they give you the list might be, so here I gave you a list of ordered pairs, but I gave it to you in a picture, right? Okay. Record your ordered pairs, apply the correct rule based on your rotation. Apply one of these rules up here to every single point, and then you can plot them and get your rotated figure. Is it okay? I just want to make sure also that we understand that they're not just haphazard relationships. You can see through the use of GeoGebra, through the use of the compass and that kind of stuff, that These are definite, well, there's logic behind them, there's reasoning behind them. Before we continue, or before I set you free to continue on homework, I want to ask this question. Take this point right there. Actually, let's move it to right there, because I don't want to use the same ordered pairs. 4, 8. Okay, so let's reflect that. Let's reflect that on that. So reflect this on the y-axis. So it goes there, right? Is that okay with everybody? Okay, so that would be my image. Okay, now I'm going to use that image as another pre-image or a second pre-image. I'm going to take that and reflect it on the x-axis. And we're going to look at a double prime. I'm going to make it an x. And we're going to ask you, how does that relate to the blue original pre-image? They've both become negated, right? Now let's move this around. Let's move that one around. Are they still both negated? Let's move it there. Are they both negated? Okay, so in the first quadrant, we see that if I reflect over the x-axis and then the y-axis, or I guess I did y-axis, then x-axis, our final image is both A and B are negated. What if I start over here? Does that still happen? Are they both negated? Started with -6, +6, and they become 6, -6. Now, the reason I don't like showing, and this is the one that is on that line y equals -x, you don't know if they flip spots, though, do you? Because they're both 6s. So let's do this. Let's go that. Did they flip spots? No, they both became negated, right? Same thing there. Do they both become negated? So I'm looking at the blue one and A double primed. Are they both negated? Aren't we doing that right there if we're negating both of them? So what's that tell you? That an x-axis reflection followed by a y-axis reflection is the same thing as 180-degree rotation. Okay, and what happens, guys? And I like to compare this type of stuff to what you're going to see later on in an algebra class. If I look at y equals x cubed, that graph right there, okay? If we take, I'm just going to take the positive part of that, so the blue part, okay? And I'm going to ask GeoGebra to rotate So I'm going to take this blue part of x cubed, and I'm going to rotate it 180 degrees. And does it become the other part of x cubed? Does that make sense? So what we want to end up finding out here is that when we graph x cubed, there's going to be some points on it that are important to us. 0, 0, 1, 1, 2, 8, and these are all points that are coming from the first quadrant, okay? If I want other points to complete the image, I need to know that this is referred to as an odd function because it has origin rotation, okay, of 180 degrees. And I can say, okay, well, if D was at 1, 1, then I should have a point of -1, -1 as well. And you can see that when I plot that, it puts this point F. If 2, 8 was on it, then -2, -8 should also be on it, and we see that it is. Does that kind of make sense? So what we learned, so my goal in college algebra is to be able to graph things like x cubed, but to do it efficiently. Well, if I can efficiently realize, okay, if I need 6 points or 7 points or 8 points to graph a function, I would rather remember maybe 4 points in this property to graph instead of 8 points. Does that make sense? I can use less information but better relationships to graph something more efficiently. Okay. So that's referred to as like I said, an odd function because it has x-axis and y-axis symmetry. Now, I reflected over the y-axis, then the x-axis. It does not matter. If you reflect over the x-axis, then followed by the y-axis, you'll get the same thing. So there should be some questions later on that target that relationship.